Hi students, this is Mr. Yao. In this lesson, we're going to continue to learn more about how to work with exponential story problems. And this is the last lesson for exponential story problems. Let's get into it. Number one, when Mr. Yao was studying vocabulary for the SAT test, he tended to forget 1/6 of the vocabulary he learned each week. Mr. Yao started with 3,000 words, write an exponential equation to present the numbers of words he still remembered after X week. Then find how many words Mr. Yao still remembered after 11 weeks. So first, let's actually change that because X is not the most representable variable. Let's actually use T. Since it's about vocabulary, I'm going to use V of T. Okay, whenever we want to set things up, we need to remember the function always looks like a times b to the x power. So we need to identify our initial value and our factor. Our initial value, of course, is started with 3,000. Okay, and in order to find the factor, we need to identify the rate. The rate is the change, and so let me write that. The rate is the change, and factor is the result. So the change is going to be forget 1/6 of the vocabulary, which means 1 minus 1/6. So since forgetting means losing, so it's 1 minus 1/6. That's going to be our factor, and it's to the t power. The question specifically said 11 weeks, which means when t is 11, so v of 11, that is 3,000 times 5/6, don't forget the parentheses, to the 11th power. And that is going to be rounded to 404 vocabulary. There you go. That's example 1. Moving on, example 2. In 1971, there were 294,105 females participating in high school sports. Since then, that number has tripled every 10 years. Write an equation to present the number of female participating in high school sports since 1971. How many female would be participating today if the trend continue till 2021? Okay, so here says tripled every 10 years. If we want to calculate how many 10 years are there, so that's why let's set it up. It's about female and it's about time. Initial value is 294105. Tripled every 10 years, it doesn't mean like a certain amount of time every year. So we need to treat it as we need to count for 10 years. So it's triple, but the time is not just going to be t. The time needs to be counted by how many 10 years we have. So it's actually going to be t over 10 as the exponent. Now let's deal with the question. 2021, 1971. So it's actually going to be 50 years past. So we're actually calculating 50. So 294105 times 3 to the 50 over 10, which will simplify to be to the 5th power. And the answer is 7146715 female. There you go. That's example 2. Moving on, example 3. The population of South Jordan grew at a rate of 8.9% from 1990 to 2000. The population in 2000 was 29,600. Find the population in 1990. So here's the tricky thing about this question. You see, it's from 1990 to 2000, and you are given 2000. So you are actually given the result, or the final amount. So this is not little a, it's not your initial value. You're actually going to be given the capital A, 29600. The rate is still 8.9%. And because the rate is grew at an 8.9%, let's change into a decimal, which is 0.089. That tells you your factor is going to be 1 plus the 0.089, which make it 1.089. As for time, from 1990 to 2000, that's going to be a 10. So let's set up the equation. Let me remind you, the equation looks like a times little a multiplied with either 1 plus or minus the r to the t power. So in this case, we actually don't know little a. It's asking you to find the little a. So we need to leave that. We actually know the capital A, the big A. So it's 29600. That equals to little a times, my factor is 1.089 to the 10th power. In order to calculate that, we actually need to find out what is 1.089 to the 10th power, and then divide it over so that we can find the little a. The 1.089 to the 10th power, if you type in your calculator, that is going to give you, so this is 29600, that equals to a times, you can choose to write down as many digits as you can, is 2.34573418881. You're going to divide that number over, so eventually round your final answer. Little a is 12619 to begin with. So that is our initial value. Moving on. Example 4. It's actually very similar. I bought my car 5 years ago. It's now worth $9,000. If it depreciates at 12% per year, what was the initial value of my car? So now worth, which means this is my final amount again. So big A is 9,000. My rate is 12%, but the 12% is actually depreciates. Turn into a decimal, which is 1.12. That means my factor is 1 minus the 0.12, which is 0.88. And it's 5 years ago, so t is going to be 5. Let's set it up. Big A is 9,000, so 9,000 is on the left side by itself. Little a, we don't know. Multiply with 0.88 to the 5th power. So I'm going to calculate what is 0.88 to the 5th power first, because exponents is before the multiplication or division. So write down as many digits as you can. So 9,000 equals little a times 0.527731916. Divided over my little a, round to 2 decimal places, $17054.11, and that was the initial value. That's example 4. Moving on, example 5. After graduation from college, Sarah is offered 2 jobs. Company A says if she signs a contract with them, they will put $10,000 in the bank account for her retirement that will grow at a rate of 10% yearly. And company B will actually give the equation right there. B equals 20,000 times 1.05 to the t power, and she must work at least 10 years to have access to the money. So company A is at a rate of 10% growing, which means the rate is going to be 10%, which makes the factor 1.1 because it's growing. So it's actually 1 plus the 10%, or 1 plus the 0.1. That's going to be 1.1. Okay, company B, well, if you already have the function given, again, a times b to the x power, the b is our factor, so that means 1.05 is actually our factor. Compared to 1, it's only 0.05 extra, so that means the rate is 5%. Just by looking at the rate, of course, company A has the higher rate. And then it's asking which company should she work for if she will work there for 10 years. So let's calculate. For company A is going to be 10,000 multiplied with 1.1 is the factor to the 10th power. And that is going to be 25937.42. As for company B, put in the formula 20,000 times 1.05 to the 10th power. And that is going to be 32577.89. In that case, clearly, for 10 years, company B is the winner here. Which company should she work for if she will work there for 50 years? That's a long time, but let's calculate. A is 10,000 times 1.1 to the 50th power. That is going to be $1,173,908.53. Company B, it's actually 20,000 times 1.05 to the 50th power, and that is going to be 229,348.00. So you see, even though company B offered more at the very beginning, 20,000, which is actually double, which is quite a bit more. It's 10,000 extra. But as time grows, you see this one got into the millions and is almost 5 times of the other one. So in this case, for sure choose company A. There you go. That's example 5. Moving on. The last example. I'm going to suggest you pause here and try to do this one by yourself. Hopefully you have tried it. Now let's have a look. Here are all the answers for that one. First, you need to use the table, which is what we have learned. If you remember, it's going to be bottom divided by previous. That's how we calculate the factor. So after you do that, you're going to find out the factor is 1.1, which makes the rate a 10%. In the second one, the equation is given, so 1.15 is going to be the factor, and it's 0.15 extra compared to 1. That's why the rate is a 15%. Investment B has a higher interest rate, but investment A will begin with 20,000. And so that's where you need to understand the dollar in thousand, which means that number is actually 20,000, not just 20. So the first one in 25 years is 20,000 times 1.1 to the 25th power, which is $216,694.12. And the second one, 10,000 times 1.15 to the 25th power, it's $329,189.53. And 25 years, even though this one starts with a lower amount, but is a higher rate, and it does catch up. So in that case, we're going to choose company B. So that's example 6, and that is everything for this last lesson of exponential story problems. Thank you.